everyone. Today we will discuss about the word problems involving quadratic functions. So in word problems, we have the two concepts. Number one here is the problems that involves the vertex point of a function. Let's have an example. Vertex is the maximum or minimum point of the parabola, wherein we have here the point hk. For example, the difference of two numbers is 18. Find the numbers such that its product is the smallest possible value. In this example, we are looking for the smallest possible value. That's why we can apply the vertex of a function. First is we need to represent the values for x, that is the first number, while y is the second number. For the first equation or the translation, the difference of two numbers is 18. So when we say difference, we will subtract the two numbers and then the result will be 18. That's why we have here x minus y is equal to 18. And then after that, we can get the y equation. So from this one, x minus y equals 18. To get the equation for y, we have to transpose x to the other side, and it will be negative y is equal to negative x plus 18. And then multiply the equation by negative 1. So negative 1 times negative y, that would be y is equal to negative 1 times negative x is positive x, and negative 1 times positive 18 is negative 18. So this is the equation for y. And then for the second statement, we need to find a number such that its product is the smallest possible value. That's why we are looking for the product, and it will be the function of this problem. So we have here the product is equal to x times y. And the product will be the function of x is equal to copy the x variable times the value of y here, or the equation for y is x minus 18. So we have x times x minus 18. And then simplify it, we have f of x is equal to x times x is x squared, and then x times negative 18 is negative 18x. Next is we need to solve for x. In order to do that, we can use the formula in getting the value of h, since h is equal to x. So from the function, f of x is equal to x squared minus 18x. Let's identify the a, b, and c values. So a is equal to 1, b is negative 18, and c is 0. And the formula in getting the h value is negative b over 2a. So we'll have negative times negative 18 over 2 times 1. So we have 2 times 1 is 2, and then negative 18 divided by 2 is negative 9, and negative times negative 9, that would be h equals positive 9. Since h is 9, then we can say that the x value is 9. So 9 is the first number. And then we need to solve for the another number, which is y, and the formula in getting the y, or the equation, is y is equal to x minus 18. Again, that is x minus 18. So we have y is equal to, the value of x is 9 minus 18. So y is equal to negative 9. And negative 9 is the second number. And for us to get the product, which is the smallest possible value, we can just multiply these two numbers, or we can use the function f of x, or it will be f of 9 is equal to, from x squared it will be 9 squared minus 18 times 9. And then f of 9 is equal to 9 squared is 81, and then negative 18 times 9 is negative 162. And f of 9 is equal to 81 minus 162, that would be negative 81. Therefore, the smallest possible value in these two numbers is negative 81. So here's the complete solution. Thus, the two numbers are 9 and negative 9, which gives the smallest product of negative 81. Okay, next example. A lifeguard has a 100-meter rope to mark off the supervised area of the beach. What is the largest possible rectangular swimming area? So if you will illustrate this one, this is the seashore. And then this will be the rope. So it forms a rectangular shape. So meaning these three sides, the total of it is 100 meters. So we can say that the perimeter is 100 meters. The perimeter is 100 meters. So for the representation, we have here the length and the width. So L is the length and W is the width. Since the formula in getting the perimeter is 2L plus 2W, while in this part we only have 1L, 1 length, and 2 widths. So for the formula or the translation, we have here L plus 2W is equal to the perimeter, which is 100. Since the side of the seashore is open, there will be only 3 sides. That's why we have 1 length and 2 widths. And then, to get the equation for L, we will transpose 2W to the other side, and this will be L is equal to 100 minus 2W. And since we are looking for the largest possible swimming area, so we need the formula in getting the area of a rectangle, and that is length times width. And then again, just like in previous example, the area will be the function of W is equal to, the length is 100 minus 2W times the width. So simplify this one, we have f of W is equal to 100 times W, that is 100W, and then negative 2W times W is negative 2W squared. And for us to solve this one, we need to write it in standard form. So we'll be having f of W is equal to negative 2W squared plus 100 W. And then after that, just like in the previous example, identify the ABC values. We have A is equal to -2, B is 100, and C is 0. And the formula in getting H is negative B over 2A. And remember that H is also the W in this function. So we have negative times 100 all over 2 times -2. So we'll have negative times 100, that would be negative 100 divided by 2 times -2, that is -4. And negative 100 divided by -4, it will give us H is equal to positive 25. So if H is 25, then we can say that the width is equal to 25, and the unit will be in meters. And then to solve for the length, we will use the equation that we derived here. So we have L is equal to 100 minus 2W. L is equal to 100 minus 2W, and then substitute the value of W. We have L is equal to 100 minus 2 times 25, and then we have 100 minus 2 times 25 is 50. So 100 minus 50, and it will give us 50, and the unit is in meters. So 50 meters. And then to get the largest possible area is we can just simply multiply this to 25 times 50, or we can substitute the value of W to the function. Okay, let's try it. We have f of 25 is equal to negative 2 times 25 squared plus 100 times 25. So we have f of 25 is equal to negative 2 times 25 squared is 625, and then plus 100 times 25 is 2500, and then for the next one we have f of 25 is equal to negative 2 times 625, that would be negative 1250 plus copy 2500. And then next is simplify this one. So since we have the different sign here, we'll just subtract it. So f of 25 is equal to negative 1250 plus 2500, that would give us 1250. And then since this is the area, we'll just write the unit square meters. And then for the conclusion, the largest possible swimming area is 1250 square meters. Okay, let's try another example, which is the revenue example. There are 100 students who ride the school bus and pay 10 pesos per day. And the school bus operator needs to increase the fare because of the oil price hike. And he found out that if he increases the fare by 1 peso, then the number of students will be decreased by 5. So from this, from 100 students, if he will increase 1 peso, the number of students will be decreased by 5, so it will be 95. So if you will increase 2 pesos, then the students will be decreased by 10, so that would be 90. But the question here is we need to know how much must be the increase in the fare so the possible revenue is at the maximum. So again, we're talking about the maximum possible revenue. So we will use the vertex point of the function. So first is we need to represent the clues here into um, expression. The first one here is we have the increase of fare is, we can represent it as P. So this will be P. And then for the number of students, since the original number here is 100, and then if we will increase 1 peso, there will be the decrease to the number of student, which is 5. So we can say that 100 minus 5p. And then for the amount of fare, since the original fare here is 10 pesos, so 10 plus the increase, which is p, so 10 plus p. So we will remember these representations. And then for us to get the revenue in this example, so we need to multiply the number of students and the amount of fare. And in this representation, the number of students is 100 minus 5p, while the amount of fare when increased, that is 10 plus p. So for the function, we will use this r is equal to number of students times amount of fare, and then f of p is equal to 100 minus 5p times 10 plus p. And then to simplify this, we can apply the FOIL method. So 100 times 10, that would be 1000. And then 100 times p is 100p. And negative 5p times positive 10 is negative 50p. So since they are similar, we can just subtract it. 100 minus 50, that is positive 50. And then copy p. And for the last term, negative 5p times p, it will give us negative 5p squared. So this will be the function. And then we need to rewrite this in standard form. So this comes first, and then followed by 50p and positive 1000. So we have f of p is equal to negative 5p squared plus 50p plus 1000. And then we need to solve for h. But before that, identify the a, b, and c values. So a is negative 5, b is 50, and c is 1000. So we have h is equal to negative b over 2a. Again, remember that the h value here is also the p value. So we have negative times 50 divided by 2 times negative 5. So we'll have negative times 50, negative 50 divided by 2 times negative 5 is negative 10. So negative 50 divided by negative 10, it will give us h equals positive 5. Since h is 5, then we can say that p is equal to 5. And remember that p is the increase of fare. Increase of fare. And then We can also solve this by using the normal calculation, like if there will be 5 pesos increase, then the number of students will decrease by 25, right? Because if 5 times 5 is 25. So 100 minus 5, 25, that would be 75. So we can just calculate it just like that. But since we are applying the quadratic function, we can just substitute the value of b to the function. So we have f of 5 is equal to negative 5 times 5 squared plus 50 times 5 plus 1000. And then we have f of 5 is equal to negative 5 times 5 squared is 25 plus 50 times 5 is 250. Sorry. So we have 250 plus 1000. And then f of 5 is equal to negative 5 times 25, and that would give us negative 125 plus 250 plus 1000. So we can just add these two, 250 plus 1000, and that would give us 1250, and minus 125. So f of 5 is equal to 1125, and this will be the possible revenue, or the maximum possible revenue of the school bus operator. And if we will check this one, again, just like what I've said earlier, since the increase of fare is 5 pesos, then there will be a decrease of 25 students. So the number of students will be 75. So if we will check this, 75, the number of students, times the fare, so that would be 10 plus 5 is 15. So 75 times 15, that is also 1,125 pesos. So for the conclusion, the school bus operator will earn 1,125 pesos with the increase of at most 5 pesos.